minus 2.
And so that will be your y-intercept.
Yeah.
How about your x, your roots?
Would you just take the 3 numbers? And those would be the roots?
So it would be x minus 2 equals 0.
Yeah, so that would be 2 minus 1 and minus 1.
2.
So that would be repeated root.
No. So this 1 minus x equals 0?
Oh, yeah, so 1.
Yes. 1.
Yeah.
And then if you were to sketch that graph, it would look something like that.
Yeah, because it's negative.
Yeah. Okay, how about B?
It's also cubic.
Yeah.
This time it just has 2 roots.
Mm-hmm.
The y-intercept is 2.
So you'd get 2, and then you'd multiply it by x.
Oh.
And so you'd get 2x equals 0. And so what is x?
0.
Yes. And so that's going to be your
root. Okay.
So you get, what are your other 2 roots?
Minus 1 and minus 2.
Yeah. Minus 1, minus 2, and then you do a cubic, positive cubic. Yeah. Any questions there?
No.
Okay, so let's all right, sketch these ones. And so the way you do these in general is you first let x be 0 and find the y, and then you let y be 0 and find the x.
Okay.
Idea about
so the y-intercept is 1.
Yeah.
And 2 roots are 1 and minus 1.
Yep. And so 1 minus 1, and this square one, do you know how you deal with that?
Not really.
Let's see. So when you expand this, you'll get a positive cubic. I see it. So this x minus 1 created the plus 1 root.
Right.
So it's going to be a cubic. It's going to be like that, except here Because it was a square bracket, it only touches there.
Yeah, okay.
And comes back off it.
Okay.
So that's the trick with the part A. How do you go about part B?
Do we factorize it?
Yeah. I mean, it's basically the same thing. You let x be 0, solve for y, let y be 0, solve for x.
Okay.
And in fact, what calculator do you have?
It's GX9750.
So we can try with solving it with your graphical one. It's the cubic. So you just do the thing is equal to 0.
Okay.
Sorry.
So we have roots of 3, 0, and minus 1. Wait, no, those wouldn't be the roots. Minus 3, 0, and 1.
So x equals minus 3, is it?
Yeah.
Okay. So minus 3, 0, and 1. And it's a positive cubic. And so it's starting bottom left.
Yeah.
There we go. And in fact, the last one, that's the exact same idea. You could put that into your calculator and solve it that way. And I think it would just be repeated too. Any questions about anything there?
For the third one, would we expand it normally, or
Don't have to. No, just put it in your calculator again. So I think when x is 0, you're going to get minus 8.
Right.
When y is 0, you're going to get 2.
Okay.
And so we have to do a cubic of this. And so it's going to look a bit like that, I think. Something like that.
Okay.
Yep. Any other questions?
No.
Okay. Yeah, so actually, and you have a graphical calculator. Yeah, it's the last one. That's the same thing. Just sketch it. I mean, you have a graphical calculator. You can solve it and all the rest.
Mm-hmm.
I think you would. Okay, here is this one. How would you go about 7 part A?
Mm-hmm. So it's cubic.
Mm-hmm.
Would we expand it and then factorize it?
Correct. You'd fully expand it, then fully factorize it, and I think you'll be fine for that. And
Okay.
the easy way to factorize it is to actually just solve it and then just get the brackets from that.
Okay.
These are quartics. For the first one, what are the roots? Part A, example 4.
Well, minus 1, minus 2, and 1 and 2.
Yeah, exactly. Y-intercept?
Minus 4.
I believe it will turn out to be +4.
Yeah, +4.
What will happen with this square bracket?
You just multiply it out, so it would just touch the x-axis
At what point?
at 2.
After you solve it, that root will give you?
4.
No. You don't expand that bracket.
Oh, -2. Yeah.
Yes, and so the root that will give you is -2, and so that's
Yeah.
when it bounces off that one.
Yeah.
How about this C?
Let's see. Roots would be -2 and -9. No, 3.
Are we looking at the same one, part C?
Actually, yeah, 7 plus.
So
Yeah, +1 and +3, right?
yeah,
Yeah.
and yeah, same thing. It touches it at just 1 point.
Yeah.
And that's what it looks like. There we go. Touches it. Okay.
Okay.
Find the coordinates of points P. All right, might as well do it. Okay, what's the equation of this graph?
So we've got x +2, and then x +1, x -2, and x -3.
When you multiply out all those numbers, what do you get?
12. There we go. Yeah.
And so what is the P value up here?
12.
Yeah. Great. I think you're fine there. So that's okay, reciprocal graphs. Just put it in your fancy calculator. Sketch on the same diagram. Yeah. Okay, points of intersection. So that's where they cross over, make them equal to each other, and solve it. I'm just yeah, okay, so now we're getting the transformations. Sketch these graphs, we're good. Okay, so what will be, how will we do part A?
Is it just a shift to the right by 1?
So what will be one of the roots on the g of x?
+2.
So x equals 2. So this is the g of x plus 1.
Right.
So that becomes x plus 1 equals 2. So what's the new x coordinate?
1.
And so it didn't move it 1 to the right. What did it do?
Moved it to the left.
Yes. So +1 in the bracket next to the x does -1 to all the x coordinates, because when you bring it across the equal sign.
Oh, okay.
So you would just sketch the g of x as normal, and then you would you just move everything 1 to the left. Another way is the g of x is x times x minus 2. What's the difference between that and the g of x plus 1?
The x minus 2 would be to the right.
What did we just say?
Oh.
What happens to the x?
Oh, it's subtracted. Sorry.
Yeah.
I think, yeah.
So looking at it a different way, they just substituted x plus 1 for x.
So it shifts to the left.
Yeah. And so what you can do is, wherever there's an x on the right, do the same thing. replace it with an x plus 1. That becomes x plus 1 minus 2. And if you want to, you can simplify it, or you can just put it straight into your calculator.
Okay.
So you can just put into your calculator y equals that, and then that will give you the new sketch, and it will look exactly like the old one, but one to the left.
Okay.
Okay, so we'll try one. Okay. This one's a little bit. I want to just practice that one if I can. Okay, let's practice with the f of x. Let's do part A then.
Would it just be x cubed minus 1?
No. The f of x plus 1, the x is replaced by x plus 1 in a bracket cubed on the outside.
Okay.
And so you just draw into your calculator that, or doing it the long way. Let x be 0, find y, let y be 0, find x.
Okay.
And do you know how to put that into your graphical calculator and see it?
Yeah, pretty sure. Go into graph. Yeah, you're doing the graph and you put it into the graph mode.
Okay.
From the menu. Yeah.
Okay. Yeah. So you replace x with x plus 1 in a bracket. If there was a coefficient of x, that goes on the outside. If there wasn't, okay. So let's say question 1. Let's do part A for part 3, for equation 3, 1 over x.
So that would become 1 over x plus 2.
Well done. And then you just sketch that graph, y equals 1 over x plus 2. And it will look exactly like that, except 2 to the left.
Okay.
How would you do question C for equation 1? What would that be?
Let's see. So x minus 1 squared.
Well done. 1 squared. Okay, now we get to the tricky stuff. Let me go back. How do we do this one? Oops. Oh no, what's that doing? Okay.
So 1 over x plus 1.
Yes, so it just has a separate plus 1.
Yeah.
Exactly, and that just goes in the calculator, and
Yeah.
that'll sketch it for you. Or if your calculator breaks, let x be 0, find y be 0, find x.
Yeah.
And so they will not give you any problems. Let's say. How would we do question 3? What would be the equation of the new graph? What would be C, part C?
C. So y equals x squared brackets 1 minus x and then plus 1?
No, this is in the bracket next to the x, and so the x is replaced with this.
Right.
So x is replaced with x plus 1. Wherever there was an x, replace it with x plus 1.
Oh, and that, okay, yeah. So x plus 1 squared brackets 1 minus x plus 1.
X plus 1. And yeah, what would this bracket simplify to?
Minus x.
Yeah, it would. 1, yeah, minus x, that's right. And if you weren't sure, you could actually just put it in the calculator unsimplified and let the calculator simplify it.
Yeah.
Okay, let's see. Yeah. I just want to see if it's pretty tricky. See the exam questions. Okay, so now. Okay. What is question 6, part B, the second one?
6b. So we have 2 instances of it, or so do we substitute all x's with x plus 1?
So that would be this previous one where you'd replace all the x's with an x plus 2.
Right.
This is y equals the f of x minus 1.
Right.
So what would that new equation be?
You just subtract the whole equation. Well, subtract 1 from the whole equation.
Yeah. And so you would get the f of x equals x squared, x minus 1, x minus 2, and then minus 1.
Minus 1.
What would change about the graph with that?
It would shift to the left by 1.
That would be if it was. You're thinking of if it's in a bracket next to the x, then it moves it up and left and right.
Is it scale factor?
This will move it up and down if it's outside the bracket, not next to the x. And so this will just subtract. This will just subtract 1 to your final answer, and so because your final answer is the y equals.
Oh, okay, yeah.
So what will this do to every coordinate on the graph?
So it would just shift it down 1.
Yes. Okay. Exam question. Let's try this one.
So would P just be 6 minus 1?
Well done. And B?
4, 2?
It will be 4, 2. Yes. Brilliant. Great. Okay, how about this one? 8. Exam question.
Okay. So y would equal 1/4?
We're trying to find what a is. So what value of a will move the asymptote? So what does this graph look like? 1/x. What is the asymptote?
It's just going to be 0.
Yeah. So the asymptote is at x equals 0 and y equals 0.
Yeah.
It's that one. So now its asymptote is at x equals 4 and y equals 0. So what value of a makes that happen?
3? No, 4.
Equals 4. Y equals 0. So y equals 1/.
1/x. So 1/4.
So let's move it there to x equals 4.
Yeah.
So in what way did it move?
No, to the right. So would it be -4 then?
Correct. Yes.
Okay.
Well done. A is equal to -4.
Getting tripped up by negatives.
Yeah.
Okay.
Everyone does. Y equals 1/x -4. Move the 4 to the right.
Okay.
Any questions about that?
No.
So reciprocal graphs, just something to get used to as well.
Yeah.
Oh, wow. Okay, let's go for this one.
Mm-hmm. So we would solve the first equation?
I suppose you could just sketch it with your calculator. And then, okay, and then the point coordinates lies this curve plus 4. Okay. How do we go about this?
Do we make y equals 0?
Yeah, okay. So when y equals 0, what is x?
Uh, uh, 0 and -2.
0 and -2. Okay. And so x equals 0, x equals -2. So what is the two possible values of a that would make this, that would give us the coordinate -1, 0?
Mm.
Give us next coordinate -1.
fine. Okay, so do we
Yeah. Go.
divide both of them by 4?
So this one is at -2. This one is
Yeah.
at 0. What transformation will cause it to go on to -1?
Y equals f brackets x plus 1.
So that would move it one to the left.
Yeah.
Is there any other way that the thing could be?
Scale factor?
No.
Or
So-
no, just x and then plus 1 outside of brackets.
That'll move it one up.
Yeah.
But it's in the bracket next to the x. So either a is 1, which would shift this intercept one to the left.
Right.
Is there any other way that this graph could go through the point -1, 0?
And shift to the right.
Correct. And then, so if it shifts to the left, the 0 root becomes -1. Or if
Yeah.
it shifts to the right, the -2 root becomes -1.
Yeah.
And so possible values for a?
Plus 1 and minus 1.
Yes, well done. So it could either be x plus 1 or x minus 1.
Yeah.
Any questions about that?
No.
Tricky stuff lies on this equation, right? Let's go for it.
So we just put that into the graphical.
Okay.
So we got a root of -3, -1 and 0.
Mm-hmm.
And yeah, the y-intercept is 0 as well.
Okay, and part B.
B. Would it just be x -2?
So, possible values for B.
Yeah. So -2.
Mm-hmm.
Would there be -4 as well? Or no, -3?
It needs to move onto the point 2, 0. So when you do x -2, when b is -2, that moves a 2 to the right, and so the 0
Yeah.
root is on 2, 0.
Right, and then we can move the one root.
Yeah.
Yeah, with -3.
Yeah.
And then the next one with -4. No, 5.
Well done. Great. Got it. That was the hardest one for there. So what do you give yourself for translating graphs?
Probably a half.
Alright. Well, you got the hardest one. Okay. Stretching graphs. How do you know when one is a translation? How do you know when one is a stretch?
Translations have they have, well, plus or minus, right?
Yeah, and a stretch?
Stretch has multiplication and division.
Correct. And the way they do the division is they write it as times a half or something like that instead of divide by 2.
Okay, yeah.
Okay, how about this first one?
So we just multiply the entire thing by 2, or x by 2.
So let's say you solved this. So 0 is equal to 9 minus x squared. So solve for x, what would you get?
3.
And is there any other number very similar that when you square it?
-3.
Yeah.
So plus or minus, yeah.
-3. So that's the original. X is replaced with 2x. What happens?
So it becomes 6 or -6.
Doesn't look like it to me. 2x equals 3.
Oh, 3 over 2.
Yes. And so what does 2x
minus,
do?
So it divides.
Yes. So 2x,
Yeah.
you multiply all the x's by a half.
Yeah.
Yep, always, because you bring it to the other side. So how about part B?
2f of x. Would that mean that x equals 6?
Yes. And so that one is just your final answer. No. What is your final answer? If it's in the bracket next to the x, it affects the x.
Well, 6 or -6, right?
This time you multiply the y by 2.
Oh.
Yeah, so
18 minus 6 squared?
It's maybe not the best. So when x is 0, what y do you get?
0. No, sorry. 9.
Yeah. And so what would it become after when it's 2f of x?
18.
Yeah. And so if it's in the bracket next to the x, it affects only the x and it's the reciprocal. If it's not in the bracket next to the x, it affects the y, and they've already brought it to the other side, so it's just times 2. So
Okay.
So it's just what it is. It's not the best example, but we'll see. Okay, so these, let's see, what has changed from part A to the first part of part B?
Well, x is multiplied by 2. So, guessing that would be f of half x?
Yeah, all the x coordinates are times by a half.
Yeah.
And then how about the next one?
It would just be f of minus x.
No, because the x's didn't change. It was just the very outside that changed.
Oh.
So I believe.
Minus fx.
Yeah. What will that do then?
Just minus the entire equation.
Yeah. So his book is jumping around. Let me deal with that in a minute. Start doing two separate things at the same time. Okay, yeah, so this one. So equation 1, what would be the new one for, 1 part A?
1 part A. Just 0?
So this and this.
Yeah. The half x squared.
So you would multiply all the x coordinates by a half, but the equation of the new one, x is just replaced with 2x.
Oh, so 2x squared?
Yeah, it's 2x squared, and what does that simplify to?
4x squared.
Yeah, and so it becomes f of x equals 4x squared. Let's see. See, these are a bit weird. In this case, show that this thing on a diagram. Yeah. How about okay, so originally that's one. See, it's probably better with a cubic. Yeah. See, they start off so simple that it's kind of even difficult to do. I like the look of question 3. Yeah. This one. Okay, how would we do part B? And you're just sketching the graph.
Right.
And I suppose it might help to sketch the first graph.
Okay.
Or if you knew how to do it with your calculator, you could go straight to part B.
So, should I say the roots of the first equation?
So yeah, okay.
So we've got 2, 0, and minus 2.
Okay. And so what will be the roots for part B?
Would it be minus 4 and 4 and 0?
Well done. And the next part?
Minus 1, 0, and 1.
4. I think, hang on, it may not be the best. It's still not a wonderful example. No, I'll get to, okay, maybe it is time that I get to that. Let's see. Yeah, let's do the exam question. about first one?
1 and minus 1.5.
It's in a bracket next to the x, so it only affects the x direction.
Oh, okay. So 1 minus 3.
Yeah. And part B?
8 and minus 12.
It's not in a bracket next to the x, so it only affects the y direction.
Okay, that's how that works. So minus 2 minus 12.
Yeah. So, yeah, there aren't many good examples for it. Let's see this one. Yeah. So how about 8?
So that just affects the x. So minus 1 and 8.
That would be if it was 2x.
So minus 4.
Yes. And then how about 9? How about 9b?
Um,
18. How does this thing work?
Wouldn't it be 2 and 3?
Yeah, it's 2 and 3. Actually, the y-intercept. I'm wrong. What would be the y-intercept for it?
6 or 18.
So you've got minus 2 times minus 3 times minus 3.
Oh, minus 18.
Yeah. There we go. So it's going to look like that. And it bounces off the other one, the square one. It now goes through the 0.10, 2 possible values for A.
2 and 3.
Yes, correct. And then extension question. How would you sketch y equals minus the f of x?
Equals minus. Is it just like symmetrical along the y-axis of the first graph?
Right. And so what will change?
So the roots become minus 3 and minus 2.
That would be if it was the f of minus x. That would change the x. This is minus the f of x.
So it's mirrored along the x-axis. So the y-intercept becomes 18.
Yeah. So the y-intercept becomes 18. What about what else?
The graph becomes positive.
Yeah. And what about the roots?
Don't they stay the same?
Correct. They stay the same. So it doesn't affect the x direction, only the y direction. So it's now a reflection in the x-axis.
Okay.
The other way, if it was in the bracket next to the x, it would be a reflection in the y-axis.
Okay.
All the x's would change sign. This way, all the y's change sign, and all the x's stay the same. And I think if you're ever stuck, just go back to the original equation and replace all the x's with a half x in your calculator.
Right.
Replace all the x's with 2x in your calculator, or whatever it might be. Replace all the x's with minus x in your calculator, and so
Okay.
on. If you're ever really stuck. So let's see, transforming functions. So, okay, so this one, let's try it.
So the first one is a shift to the left by 1.
Yeah, so what will the coordinates become?
0, 4, and 2, 1.
And the origin?
Oh, the origin. Minus 1, 0.
2, 1. How about part D?
D. Ooh. Just multiply the entire thing by 2. Is it just multiplying y by 2?
So if you were to make it y equals, what would it be?
F of x over 2?
Yeah, or you could write it as a half f of x.
Half f of x, yeah.
And so
multiply everything by a half.
Yeah, and by everything you mean?
Y.
Yes, all the y coordinates. So what would they become?
So 1, 2, origin would stay the same, and 3.5.
Well done. B becomes 3.5. How about E?
So that would be y equals f of x plus 1.
Well done. And so what?
So everything shifts down 1.
So you brought it to the other side. Let me. Yeah, you brought it to the other side. So y is equal to the f of x. The f of x is like y.
Yeah. So is it up 1?
Yes.
So,
yeah. And another way to think of it is if x is replaced with x minus 1, that moves 1 to the right. In this case, y was replaced with y minus 1, so that moves it 1 up.
Okay.
But the f of x plus 1, if it's outside the bracket, it's in the y direction and it's already been moved to the other side.
Okay.
So the f of x is the y coordinate, and so it's just that plus 1.
Okay.
But not easy stuff. That's a good one. And then it's just these questions. They're very similar. Yeah, you're good there. Within the coordinates. After each one. Yeah. And then it's just mixed exercises. So yeah, I think just practice them.
Yeah.
Because there's a lot to it. So translations, adding and subtracting. What is it? Stretch is multiplying or technically dividing, but they just do multiply by a half.
Yeah.
And then a reflection is a sign change. So they change x to minus x or f of x to minus f of x. In the x direction, it's always the opposite, and in the y direction, it's usually the same, and that's because they've already brought it to the other side.
Okay.
They already made it y equals. How was that for you, Mieszko?
Oh, that's good. Yeah. I'll have to practice, but yeah, that was helpful.
So they do take practice, I have to say, because of the backwards stuff, you know.
Yeah.
So anything in particular you want to do next week?
Did we manage to finish motions and forces?
No. Do you want to finish that?
Yeah, that might be good.
Okay. Any questions for me in general?
No. It's same time next week, I believe.
Yes, I'll be back to 2.
Yeah.
Yeah, sorry again about today.
No, that's fine.
All right, well done, Mieszko. You did great. And
Thank you.
look forward to chatting again.